Hello everyone. I'm Nikta Kanchara from Group 6. My team members are Yugandhar Reddy Vangala and Venkatayappa Reddy Gunta. And we are going to discuss about two separate publications which will be shown in this presentation. One is comparative analysis of search algorithms. The others are Maharshi J. Pathak, Ronit L. Patel, Sonal P. Army. And other paper is a severe weather avoidance using informed heuristic search. Others are S. Bocadia and J. Walasek. I'm going to discuss about a comparative analysis of search algorithms, which was written by Maharshi J. Pathak, Roni L. Patel, and Sonal P. Army. Here, the study of how to make a computer think like a human is known as artificial intelligence. Here, artificial intelligence is a large field of study. Next one. This study here a machine learning and a deep learning are two subfields in artificial intelligence, whereas artificial intelligence, machine learning, deep learning, and data science are all interconnected areas. Problem solving, knowledge and reasoning, adversarial search, which comes with a game playing, uncertain knowledge and reasoning, and expert systems are all examples of artificial intelligence. The study that follows goes into further detail regarding problem solver approaches in artificial intelligence. In artificial intelligence, we have two problem solving techniques. One is uninformed search and other is informed search. The study, this paper mainly focuses on breadth first search, depth first search, and uniform cost search, A star, and the best first search in further detail. Next, here comes we have as I told earlier, like in artificial intelligence, we have two problem solving techniques: uninformed search and informed search. Uninformed search is nothing but a blind or brute force search approach that encompass search strategies such as a breadth first search, depth first search, uniform cost search, iterative deepening, and bidirectional search. Uninformed search does not include any information about the number of steps required to go from the present state to the objective state. It will evaluate the option that appears to be the most promising at the time rather than best approach to the objective. Coming to informal search, it is well performed search is essential to solve a problem. Heuristic search employs a heuristic function. It employs a generate and test strategy. It includes algorithms for hill climbing, hardest hill climbing, A star, Evo star, and best first search. Uninformed search is less efficient compared to informed search. In informed search, the heuristic function is employed as a model to guide us to the desired state. The educated search will not go through the search tree mindlessly. It will choose the next node to transverse based on some evaluation function in order to achieve the desired state from the present state. Next, we have in this paper, as we discussed earlier, we are going to discuss about five searching techniques. One is a breadth first search, depth first search, uniform first cost search, A star search, best first search. Coming to first one, a breadth first search. Here, all nodes are extended level by level in breadth first search. It initially expands all the nodes on first level of the search tree, then all the nodes to on the second level, and so on until it reaches the objective. In this, the frontier is realized as a queue that operates on first in, first out basis. It is a poor approach when all solutions have a long path length or when some heuristic information is available. When the memory need is large, it is not used. Time complexity is O of BD and space complexity is O of BD, and where B is the branching factor and D is the depth of the solution. Consider the graph. The table shows the open and closed list for BFS. The open list contains nodes that have yet to be research, whereas the closed list contains nodes that have already been studied. Node 1 is extended initially at level 0. The queue is filled with the children of nodes 1, 2, 2, 3, 4. Then using the first in first out technique, node 2 is extended and the children of nodes 2 to 6 are added to the queue. This is how search gets to the desired condition. Next, coming to depth first search. In this, expansion begin at the source code and progresses to the deepest unexpanded node in search of destination node. In this, the frontier is realized as a stack that operates on the last in first out principle because it is implemented using the stack. It is also known as recursive algorithm. Time complexity is O of BM and space complexity is O of BM, where BM denotes the branching factor and M denotes the greatest depth. The table displays the open and closed list of DFS. Node 1 is extended initially at level 0. The children of 1 to 4, 3, 2 and 2 are added to the stack. Then using the last in first out technique, node 2 is enlarged and a children of 2 to 6 is added to the stack. Node 6 is then enlarged. Because it has no children, it will go back to the node 3, which will be enlarged. Nodes in the depth are increased in this manner and the search progresses to the desired state. Here, depth first search is useful when memory is a finite source. The sequence in which a node's neighbor are added to the stack can be modified such that solutions are discovered on the first try. It is a terrible strategy when it is possible to be captured in an infinite number of ways, which occurs when the graph is infinite or when there are cycles in the graph. We are using applications detecting loops in a graph, identifying components of a graph that are closely related, finding the solution to a conundrum that has just one solution. Coming to next one, a uniform cost search. Here, uniform cost search adds a low cost path to the node. The priority queue is used to implement it. Consider an equation to compute the cost of each node. C of m is equal to C of n plus C of nm, where C of m is the current node's cost, so C of n is the previous node's cost, and C of nm is the edge weight. The successor can be deleted if it is already in a queue with a higher cost. Time complexity is O of B1 plus C into C star divided by E, and space complexity is O of B1 plus C star divided by E, where C is the best solution cost and each activity cost at each. Table shows the open and closed lists for uniform cost search. Here it is useful when the amount of space required is reduced, when intelligent isn't necessary, or when the evaluation function isn't needed. The use cases are solving the maze issue, finding a path. Next one, coming to A star. A star combines the best of uniform cost search with a pure heuristic search to get the best answer. Consider the following equation for determining the cost of each node. F of m is equal to C of m plus h of m, where C of m is equal to C of n plus C of nm, and h of n is a heuristic function. F of m calculates the lowest aggregate cost. At each node, the most reduced value of f is picked for expansion. As a heuristic function, Euclidean distance, Manhattan distance, and or a diagonal distance are used. If the f values of two nodes are the same, the node with the lowest h value is picked for expansion. Where a goal for expansion is chosen, the calculation comes to an end. To get an optimal solution, an admissible heuristic function h of n into h into N. Returns a visitor's node from the closed list to the open list. Time complexity is O of BD and space complexity is O of BD, where B is a branching factor and D is a depth of solution. The example is related with an open and a closed list. The steps we follow to goal state from the source is begin with the source code and add it to the open list, investigate all nodes that are near to the node in the open list, determine the cost of each node detected in step 2 and arrange them in increasing cost order in an open list, transfer the current working node from the open list to the closed list. The first node in the open list becomes the current working node. If the current working node is not in the desired state, repeat steps 2 and 5, which is investigating all nodes that are near to the node in the open list. And fifth one is the first node in the open list becomes the current working node. The shortest path is given by the close the list, and the value of the last cost function found is the ideal cost. The applications use cases which we are using in this are a navigation system for traffic, playing games, finding the shortest path, and autonomous surface vehicles course is replanned in real time to avoid underwater obstacles. Next one, the final one is a best first search. It is a combination of a breadth first search and depth first search. The priority queue is used to implement the best first search. Depth first search has the benefit of providing a solution without computing every node, while a breadth first search gets to a solution without searching. It is certain that the technique will not be caught. For best first search is a combination of these two, with licenses transferring across a path. At each step, the best suited node from among the produced ones is picked to facilitate growth. This node may have a place to a similar level or a different level, and so on. Switch between a depth first search and a breadth first search. It is often referred to as a greedy search. Here, the time complexity is of BD and space complexity is of BD, where B is a branching factor and D is a depth of the solution. The applications which we are using in this best first search is playing games and crawler for the web. Next slide, comparison of various search algorithms. The algorithm's performance is measured using 4 parameters, which are as follows. Now, one is a time complexity, which is the amount of time it takes the algorithm to discover a solution. Other one is space complexity, the amount of memory required by the method to complete the search. And optimality, the algorithm's solution will always be optimum or not. Final one is completeness. Is that a computation guaranteed to yield an answer when it says it does? Regardless of whether the search algorithm is exhaustive, this part is a Boolean marker. And conclusion, we comes to the conclusion that heuristic search is more efficient and acceptable than blind search. From the preceding example, it is evident that in a uniform cost search, 11 nodes must grow to achieve the desired state. In A star, just 6 nodes are required to expand in order to achieve the desired state. Furthermore, UCS takes more time than A star. As a result, A star outperforms uniform cost search in terms of efficiency and optimality, also when all methods costs are comparable. Breadth first search is preferable than a uniform cost search because it always extends the shallowest unexpected node. As a result, a heuristic search discovers a better answer than blind search. Yeah. Next, my team members are going to explain. Thank you.
Thank you, Nikita, for explaining about comparative analysis of search algorithms. I am Yugendra Reddy Vangala, along with my teammate I am Ayappa Reddy, going to explain about severe weather avoidance using informed heuristic search by Sangeeta and John. This paper explains about the safety precautions taken by the aircrafts when there is a bad weather condition. Here, a calculation is produced for general flying aeroplane, which takes a radar picture of the rainstorm as the info and decides the most secure way around with least diversion. There are many techniques used to determine the calculation for this problem, but the algorithm A-star search is created to solve these airplanes issues. A calculation for A-star search utilizing the heuristic capacity is created and used to decide the flight way in some example cases. Coming to weather information, next slide. Any unpleasant environment characteristic is known as outrageous environment. These climatic circumstances relate to the limited areas of strong breeze shear, horrible updrafts and downdrafts, and profound tempests. Strong breeze can hurt the plan of the plane, while updrafts or downdrafts can cause an enormous change in the tallness of the plane and can make the pilot lose control over the plane. The information is required to the pilot incorporates radar reflectivity, wind speed and bearing, icing seriousness, and temperature. To imitate a radar picture, a 2D Gaussian limit is picked to give the power of environment whenever due to rainstorm. The general standard of thumb for the safeguard of passage of a plane is to avoid the regions with power more than 30 decibels. Coming to the next one, coming to A-star search algorithm. A-star search is an educated pursuit strategy which centers around decreasing the complete cost. In the above condition, G is the out of out cost remembered for arrive at a hub N, and H is the heuristic capacity gives the assessed cost from hub N to objective state. At each and every stage in A star, a node with minimum value of function of f value is selected and expanded first. Heuristic function is accepted when the actual cost in reaching goal state is greater than or equal to the estimated cost. In developing the weather avoidance algorithm, there are some limitations. Next slide. Uh, Coming to, there are some limitations. Let's talk about the limitations. First one, least segment length. Distance between any two vertices in the flight way ought to be more noteworthy than or equivalent to a fixed least distance. This is fundamental in decreasing the pilot's overland. This is taken consideration in calculation by setting the base difference between the two hubs. The second one, maximum turning angle. Average turning in flight ways having a head change is under 60 degrees. However, in any circumstance, it ought not surpass 90 degrees. The third one, least number of turns. Generated flight way ought to be directed and a way ought to have less number of turns. Climate aversion calculation ought to have this option to fulfill all the above limitations, either in the advancement of heuristic capacity or by dimensioning the quantity of hubs. The last one, coming to the thunderstorm avoidance algorithm, the computation was explained with clear circumstance where an indirect worm brain lies on flight way. Prior to beginning the hunt, the length of the unavailable area is determined. Depending on chosen minimum portion, length, and least number of turns, length is isolated into k segments. Along each section line, an opposite line is attracted to the first way and hubs are to be chosen on this length. You can see in the picture, all the hubs lie on similar fragment have same profundability. In order to deal with memory, the adjustments are made. These progressions are made in the lines of SMS star. The SMS star is one of the algorithm, search algorithm. In SMS star, memory of the best forgotten length is held to keep away from recovery of hubs. The next results will be explained by my teammate. Thank you.
Hello everyone, myself I am Venkatayappa Reddy. Here I am going to discuss about results. The algorithm described above is used to solve several real-world problems. The grid size is 1 mile by 1 mile in all circumstances. From figure 4 shows that the radial image of stationary thunderstorm in the first condition. The beginning and conclusion points are visible and thunderstorm is located within the flight path. The inaccessible region is determined using the definitions above. From figure 5, shaded area depicts the inaccessible area corresponding to figure 4 radar image. Point 1 is the straight point and point 2 is ending point. And the shortest flight path between point 1 and point 2 that avoids the thunderstorm is obtained after tracing in inaccessible zone using effort approach. From figure 6 depicts the flight path in relation to inaccessible locations, whereas figure 7 depicts the flight path in relation to the radar image. On the radar image, the minimum segment length is 8 units. Coming to next slide, algorithm convergence and stability. The algorithm was also tested on wide variety of other test situations. In a variety of scenarios, the algorithm fails to provide a solution. Because of these reasons, the algorithm does not give satisfactory results. Those are, if the path beginning point is within area of heavy thunderstorm activity, the algorithm fails to compute the safe diversions. Because of algorithm, always try to find a solution. Sorry.
Yeah, it's clear, Ayappa. You can continue.
Clear?
Yeah, it's clear. You can
Because of
continue.
algorithm, always try to find a solution in forward direction. If the algorithm is flanked by thunderstorm in all forward heading directions, it will be unable to retrace the course to avoid the thunderstorm. The algorithm won't let you adjust your heading more than maximum turning angle. Coming to next slide. Algorithm convergence and stability. At some point in above cases, the planned path passes quite close to thunderstorm with a strong intensity. This can be avoided by lowering the inaccessible region lower intensity limit. Regions having an intensity greater than 2 decibels are marked as inaccessible in the algorithm. By increasing the restrictions to say 20 decibels, safe route can established. Ability, this will result the large deviations from the initial flight path. Coming to next slide, algorithm convergence and stability. The algorithm will give fine results if given area is small on the map, given the shortest segment length and fewest turns. On the other hand, algorithm should also be able to adjust minimum segment length depending on the severity of storm. Because of the algorithm will give of 4 of these results. First one is the better results, greater flexibility, generate smooth and feasible turn, reduce the number of turns in final flight path can be reduced as a result. Coming to summary and conclusion, in research, a severe weather evidence algorithm for the general aviation is created. Next one is, this algorithm is based on A-star search principle, which appropriate modifications based on SME search techniques to reduce the time and space requirements. The problems modeling ensures that assuming the underlying assumptions are correct, the algorithms will generate a safe flight path in short amount of time. The technique is applied to 5 different thunderstorm scenarios, and the simulation results for moving thunderstorm are provided. The finding shows the algorithm calculates the safest and shortest path in in a small area of map correctly. In addition, the A-star search technique has been modified to ensure the answer is found in the short period of time. Although these changes are jeopardize the solution optimality, they are not a severe problem when applied to situation at hand. The search tree has the finest depth, which may be calculated based on number of turns permitted in the flight path. The simulation findings are also promising, albeit the system can be fine-tuned and even better results. And these are the references that we use it for these slides. Thank you.
Thank you.